In this video, we're going to look at an application model that comes from the business world. And before we get too far, we want to make sure we understand a few key terms. So first of all, we have revenue. Revenue is simply the money that comes in. Okay, so you are making something and you sell it. It's whatever comes in. Cost is simply all your expenses. Okay, and then profit would be what is the net of both of those things. So we think of revenue, and we have to take away your cost. Okay, so you need to kind of keep those three things straight. If the question is just asking for revenue, all you worry about is how are they going to show money that comes from this operation. But if they want profit, you have to factor in the expenses or the cost as well. So here is our example. The Sweet Drip Beverage Company sells cans of soda pop and machines. It finds that sales average 26,000 cans per month when the cans sell for 50 cents. But for each nickel increase in the price, the sale per month drops by 1,000 cans. And a couple parts here. We're going to just take it a chunk at a time. First of all, it says determine a function R of x that models the total revenue realized by this company, where X is the number of 5-cent increases in the price of the can. And so I think that this little line right here is important because they are telling you what your variable should be. You're trying to find revenue, and you're going to base it on whatever X stands for. Okay, so in part A here, we need to think about how do we come up with revenue, the money that comes in from this operation. And in this example here, if you thought about it originally, if they're just selling 26,000 cans and they sell them for 50 cents each, the money that comes in is just 26,000 times 0.5 for 50 cents. And so you're going to come up with $13,000. What we need to do is factor in what these price changes are going to have, what effect they'll have on the situation. So every time that we raise the price, we're going to lose 1,000 cans. So maybe to start off, we need to think about the number of cans, and we're going to multiply that by the price per can. Okay. So typically, initially, the number of cans was 26,000. So that's still going to be part of our function here. But every time we raise the price, they're going to lose 1,000 of those cans. So I'm actually going to subtract, and I'm going to lose 1,000 every time X goes up by 1. So if I don't make any price changes, X is 0, and I'm still at 26,000. Okay, then I need to think about what's the price per can. Well, again, we start at 50 cents or 0.5. And if I increase the price, every time I increase the price, I'm going to be adding 5 cents. So it's the number of cans times the price, but then we have to factor in what this variable of X does to each one of those. For the first number, it drops by 1,000 each time, and for the other number, it raises by 0.05 each time. Okay, so that is our equation for letter A. Now in part B, they say find a graph for R of X. I don't have a way of showing you my graphing calculator for this particular video, but what I want you to do is just type this into Y1 just the way it is. You don't need to FOIL it or make it any simpler than that, but enter it into your calculator, and you have to logically think about what your window setting should be. X is the number of price changes, so typically it's probably going to be a positive number. I suppose in this case you could make it negative as well and just see what happens if they lowered the price. Maybe they would end up selling more. I don't know. But you also know what the Y sort of thing stands for. It's revenue. So how much money do you think that they would make? We already talked about at the very beginning, without any price changes, they're earning $13,000. So it kind of gives you an idea of where you should set your graph. So if you want to, go ahead and just pause the video, enter this in, and see if you can come up with a realistic graph of what we're looking for, knowing that we're trying to show a maximum for revenue. So if you spend a little time trying to graph it, this is what you would come up with. If you set your X values from about 0 to 26, remember that stands for the price changes, the number of nickel price changes, you'd get a graph that kind of looks like this. If you set your Y values to about 20,000, which again that stands for your revenue, you get this kind of upside down parabola. It takes a little bit of time sometimes to find what that window setting should be, but if you think about it realistically and you remember what X stands for and what Y stands for, it gives you a basis of where to start. Then you just have to add or subtract a little bit each time. So what we're looking for, this was kind of the answer for part B here. Okay, but what we're trying to do is figure out in part C, what should they charge per can to get that maximum revenue, and then also what is the maximum revenue. So on your calculator, you hopefully know how to find that maximum value there. That maximum value, if you calculate it, is 8, 16,200. Okay, so now we are able to maybe answer part C. Okay, first of all, they ask what should we charge? Well, 8 is not the price, 8 is the number of price changes that they've had. So if they were to add 8 nickels, think about how much money that is. 8 times 5 is 40. So they're going to add 40 cents to the original price. That means in the end, the price is going to be 90 cents per can. Okay, so that's one answer. And then what is the maximum revenue? Well, the Y value of that point is the maximum revenue. Okay, so we'd say 16,200 is the maximum revenue. You should also think a little bit about how much are they selling then. If they have made 8 price increases, that means that they've lost 8,000 cans. If they started with 26,000, that means that they must have 26,000 minus, let's see, what did I just say here? Minus 8,000 would leave you with 18,000 cans that they're selling, which is not really part of the question, but maybe still something to think about. So hopefully if we did 18,000 cans times 0.9, we would get the price that we have listed right there. Okay, so these were kind of the two main answers for this question. I am going to stop right there, and we will cover the other example here in just a little bit.